Okay, so we're now going to cover our last two reactions, and we're going to cover them together because they're very similar. So if you look here, these reactions are a little bit different because they are no longer alkene addition reactions. They're called oxidation reactions. We're not going to be adding to the alkene. We're going to be breaking it and oxidizing it. Again, we start with alkenes as our starting material. But what we're going to see with this reaction is we're now going to break the sigma and the pi bond. We're going to completely break the double bond. Okay, we're going to break our double bond for both of these reactions. Okay, we're going to break the double bond for both of these. So reaction 11 is using ozone as our oxidizing agent. Reaction 12 uses KMnO4. All right, so let's look at reaction 11 first in ozone. Ozone is O3. Okay, ozone is O3. And there's a couple of different ways to write this. You can write O3 and DMS. DMS stands for dimethyl sulfide, and that is sort of a reducing agent that that breaks apart the molecule. So I can write this just as one step, right, where I have a comma in between these two. Some textbooks like to have this as two different steps, where it's step 1 ozone and step 2 DMS. And lately I've just sort of allowed students, or you can just simply write O3. All right, so in some of our answer keys and things, you might see this written as one step with DMS, or two different steps, or it's fine for you just to write O3. All right. So what I want to show you about what this reaction does is O3 is going to break the double bond and then simply add double bond O's to both sides. Okay, so you're going to break the sigma and the pi bond and add double O's to both sides. All right, so if we kind of clean this up a little bit and look at this reaction, in our top reaction here, when we break these bonds here, we have 1, 2, 3 carbons, 4, 5, 6, right? Carbon 2, 1, 2, 3. Carbon 2 is now going to be, instead of 2 being connected to 4, 2 is going to be connected to our double bond O. Carbon 4, 5, 6, instead of carbon 4 being connected to carbon 2, carbon 4 is also going to be connected to a double bond O. All right. If we look at our second example, the same exact thing. We have our alkene. Okay. I'm going to number our carbons here. Again, I'm not numbering them to name them. I'm just numbering to help keep track. Right? If I'm not asked to name it, I can number it however I want. I'm just trying to keep track of carbons. So here we're going to break the bond between 2 and 6. So if we number our carbons 1, 2, 3, 4, 5, 6, carbon 2 is again connected to a double bond O instead of being connected to carbon 6. And carbon 6 is connected to a double bond O instead of being connected to carbon 2. All right, pretty simple, pretty straightforward. What I want to do here is I just want to highlight, right, in this example, the functional groups we're making, right? So if we start with a chain, we've now broken that chain up and have formed two molecules, right? We've formed two different molecules. A reminder of the functional groups: the molecule on the left is a ketone, the molecule on the right is an aldehyde. If we start with a ring, right, so if we have a molecule that's a ring, that's going to break up and that's now going to form a chain. All right, that'll form a chain. And again here, this part of the molecule, that's a ketone functional group, and the other side is an aldehyde. All right. And then just to emphasize and help you with the next reaction, right, let me just clean this up a little bit. What you're going to see here is I want to remind you there's a hydrogen here on the double bond and a hydrogen here. And those hydrogens are still present, right? So when we numbered our carbons, 6, 5, 4, 1, 2, 3, 1, 2, 3, 4, 5, 6, carbon 4 got the double bond O, and carbon 4 still has a hydrogen, right? We don't have to show it because it's assumed. When you look at carbon 6, that had an H, that still has an H. It's still there, okay? So the functional groups we see are generally going to be ketones and aldehydes when we use ozone. So now let's look at KMnO4. What's the difference in this reaction? So when we use KMnO4, we're going to do the same thing. We're going to be breaking the sigma and the pi bonds. We're going to be adding double bond O's to both sides, okay? But the key piece is that hydrogen that was here, the hydrogen that was here gets oxidized where that hydrogen becomes an OH. That hydrogen becomes an OH. So if there's carbons on either side, nothing happens, right? You still just add the double bond O. But if you have a hydrogen attached to an sp2 carbon, that hydrogen becomes an OH. All right, that hydrogen becomes an OH. All right, so if we number our carbons, again, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Right, you can have, it doesn't have to have 6 carbons, obviously. I guess I just tend to like examples that have 6 carbons. It's important to note that the KMnO4, right, same thing, the chain, the chain becomes 2 molecules. We just have to remember now that that H became an OH. And at carbon 6, that H becomes an OH. So that's the key difference between these. With ozone, right, with ozone you have an H and it stays an H, giving you ketones and aldehydes. With KMnO4, that H becomes an OH, so the functional groups that you're getting out here are generally ketones and not aldehydes, but carboxylic acids. All right, carboxylic acids. So let's just look at one more example here. All right, so I'm going to draw kind of a new molecule. And in this case, I'm going to draw a molecule that has multiple double bonds. Okay, molecule that has multiple double bonds. So if we treat this with ozone, with O3, we're going to assume we have as much ozone as we want. So we're going to just assume that we have an excess of this. We have as much as we need. We're going to do the same things, right? We're going to break these double bonds and add double bond O's on each side, right? So on the left here, we'd form a double bond O and a ketone, plus on the right, a double bond O, right? That chain continues. Now we form another double bond O. There was an H here, that stays an H. And then we continue on the other side. We draw another aldehyde as well, right? And just notice, it's fine for me to include the H. It's okay to not include it, right? So there is an H here, okay? That carbon's got to make 4 bonds, but I don't have to draw it, okay? It's fine if I don't draw it and I just leave it like that. So in this example here, we are really forming 3 molecules. One here, one there, and one here. All right, and anytime you have these H's, right, those H's stay. What happens if we take the same molecule and now react it with KMnO4? Okay, we're going to do the same thing. We're going to break here and break here, but what do we have to remember? The H's that are attached to the sp2 carbons, become what? They become OHs. So when we draw in our products here, we would get out our ketone, another ketone functional group here, but now this carbon will get a double bond O, and now we have our OH because it's KMnO4, okay? And one more molecule, that piece there. Again, because that has an H, that H becomes an OH here, right, when we use KMnO4. So in both examples, we still get 3 molecules, right? 3 molecules. In the top, we have ketones and aldehydes. Ketone, ketone, aldehyde, aldehyde. In the bottom, we have ketones and carboxylic acids. Ketone, ketone, carboxylic acid, carboxylic acid. And essentially what happens with KMnO4 is you actually form the aldehyde first, and then it continues to get oxidized to the carboxylic acid. So you actually form the aldehyde, and then it continues to react where you form the carboxylic acids when you have that H, all right? So for these examples, we're not going to worry about the mechanism. Okay, so I'm not going to ask you the mechanism, and you don't really need to know it. We just need to know the reactions and the products we get. Okay, so to summarize, these are oxidation reactions. Break the sigma and the pi, right? Get out ketones and aldehydes or ketones and carboxylic acids. And just have to remember with KMnO4 that H becomes an OH.